mark.
Responding to the Air Force challenge to create an Atlas II launcher design, we have evaluated two launcher concepts. Both concepts accommodate the Atlas IIe, the General Dynamics selected growth vehicle, as well as provide for an additional 10% margin above governing limit load conditions. Using our electronic Pathfinder workstation, we have modeled the existing launcher system operations and the two selected concepts. The Category 1 launcher concept retains, in principle, the present vehicle launcher hold-down approach, while maintaining the current Atlas vehicle and launch pad interfaces. The Category 2 launcher concept is a pedestal configuration, which has hold-down and controlled release capability. However, vehicle and launch pad interfaces require modification. Both categories comply with range safety requirements. Here we see a model of Cape Canaveral Air Force Station's Launch Pad 36. Before mating with the Atlas booster, the launcher is rotated to the horizontal position. Once this is complete, the launcher heads are rotated away from the center, allowing the booster to be moved into position for mating with the launcher. During erection, the Atlas booster and trailer are rotated by an erection beam to the vertical position. Once booster erection is completed, the trailer and erection beam are rotated down, and the trailer is removed from the launch pad. Next, the mobile service tower is moved back. During initial launch release, the T-frames and launcher heads are rotated back, allowing for vehicle clearance during launch. Prior to installation of the new launcher, the old launcher must be removed. The first task is to remove the structure between the launcher and the launch pad. The main launcher structure is removed and moved to storage for disposal. Next, the erection beam is removed. Finally, the two rotation end frames are removed. The Category 1 launcher is a retraction concept with hold-down and release capability. Prior to installation, some structural modifications to the launch pad are necessary. After the modifications are complete, the new launcher is moved onto the launch pad and secured. With this configuration, it's a one-step process. Vehicle and launch pad interfaces are similar to those of the current launcher. As a result, it requires minimal modifications to the vehicle. It's simple, reliable, and designed for weld accessibility. Here, launcher tests verify the dynamics of the launcher heads and T-frames. A launcher rotation test verifies the cantilever erection using a screw-jack type mechanism. The mobile service tower is positioned with the launcher ready to accept the Atlas booster. The procedure is similar to the current erection practice. However, in this scenario, the booster is rotated up without the use of the erection trailer. This, of course, eliminates the need for an erection beam. The Category 2 launcher is a pedestal concept with hold-down and controlled release capability. As with the Category 1 launcher, structural modifications to the pad are required, and installation of the launcher is a one-step process. Validation testing is similar to that of the Category 1 launcher, but we also need to conduct a Quad 3 pedestal rotation test. This is required to accommodate the Atlas vehicle engine exhaust duct clearance requirements at vehicle release. A launcher rotation test verifies the cantilever erection using a screw-jack type mechanism. The mobile service tower is positioned. The launcher is rotated down, and the launcher and booster are mated. In this concept, the booster is secured by vehicle pedestal longerons with mechanical fittings that are pyrotechnically actuated for vehicle release. Shown here is the Atlas 2AS vehicle configuration. In the foreground is the Quad 3 rotating pedestal, next to the vehicle's engine exhaust duct. Notice the rotation of the Quad 3 launcher pedestal avoiding contact with the turbine exhaust duct during launch.
3, 2, 1, 0, liftoff, and we have liftoff.
At Space Systems Division, our electronic pathfinder operability analysis tool enabled us to identify a number of design constraints early in the conceptual design phase. Our approach has combined the design and operational baselines in an electronic environment to provide lower development and operational costs. Both launcher concepts provide highly reliable and operationally efficient designs that can meet the needs of the Atlas II family of launch vehicles well into the 21st century.